Thank you for joining us here in the Phoenix Valley, where it is bright and sunny and hot. But yeah, we're grateful to have Jeremy from the great land of the North to come teach us about Go from a C# perspective. Jeremy has had lots of great experience. If you've noticed his Pluralsight course on C# things, he has quite a few and they are amazing. And I love that you've now started digging into other languages and taking those learnings from those languages and bringing them back. I did a similar experience from C# into Node and learned a lot. Node callbacks and C# lambdas are really similar. To that end, what can we learn about Go that'll help us with our C#?
Quite a bit. And some things that are interesting is that one thing that I found is that C# is starting to kind of steal things from Go that you might not know about. So for example, one of the features I'm going to show tonight is channels, which is something that can help you out with asynchronous programming. And channels were added to C# and kind of quietly, nobody really talked about it with .NET 3.0, .NET Core 3.0, I should say, whatever versions we're doing these days. And there's a lot of other things that, Go has a simplicity to it that is refreshing. I'm sure that it gets frustrating at times, but there are some interesting ideas that we can take from it. And so that's really what I'm here to talk about, because I'm not an expert. And that's the first thing I'm going to say. But before that, I'll point to my website, which is up on the up on the screen right now. So if you go to jeremybytes.com, you'll find these slides. There's a link to a GitHub repo, and that has links to a whole bunch of articles that I'm going to be pointing to if you want some more details on some of the things that I'm talking about tonight. If you want to follow me on Twitter, I'm at jeremybytes. And if you have any questions, feel free to unmute and holler at me. I'm going to try to keep an eye on the chat, but I'm not always great at that while I'm talking because I get overexcited about things and just keep going.
I can help proxy questions as it comes through.
Yes, I appreciate that. Thank you, Rob. So again, I'm not an expert. My primary language is C#, and I'm looking at different environments for different ideas. Go is one that popped up a couple of years ago, is kind of when it caught my eye and I kind of looked at it a little bit, didn't really dive in too deep. And then last year, I started getting into it more and revisiting it and finding some interesting things, and then finding things like, hey, this concept is actually moving into the C# world. So how is it similar? How is it different? That sort of thing. And so it's interesting when you look at a different environment, because at that point you're looking at, okay, well, you know what, this environment has different priorities and different approaches to programming. And are there things that I can steal from this to make my life easier? So I'm not planning on being a full-time Go programmer. I'm not ruling it out either, but I'm really approaching this from how can I make my day-to-day programming better regardless of the environment. A little bit about Go itself. It was created by Google. It first released in March 2012. That was the 1.0 release, but it's Google, so there were betas for a long time before that. And it was designed as a general purpose language that has a C-like syntax. So it has curly braces. So if you're familiar with curly braces, you should be pretty happy there. It does have static typing and memory safety. So for example, there are pointers in Go. However, if you try to run off the end of a pointer, then you're going to get a panic. And I'll talk about panics a little bit as we go. It is a garbage collected language, so you don't have to worry about freeing your memory. And it is, there's concurrency built in, and we'll see just how built in that concurrency is. And it was designed for runtime efficiency. So it's designed to be fast. I won't talk about my experiences with that because I don't know, and I'm not building the kind of stuff that people would be benchmarking. So some of the things that I'm going to be kind of pointing out that are either similar or different to the C# environment is first, Go has a very opinionated syntax. So where you put your curly braces is important. If you put your curly braces in the wrong spot, it won't compile. Another thing is you're not allowed to have unused variables. If you declare a variable and don't use it, compiler error. You can't even build. As I mentioned, concurrency is baked right in. And as someone who has struggled with task and the complexity of task in the C# world, the concurrency is kind of refreshing. It is a lot more limited in what you can do. Task in C# is awesome because it's really powerful, and it's terrible because it's really powerful because there's a lot of complications in there. And then we'll look at deferred calls, and defer is something I really like. We'll see that. I'm not going to give any spoilers on that one. Error handling is a lot different in Go. The philosophy towards errors is a lot different, and we'll look at that. Another thing is that functions can have multiple return values natively. So in C# you can kind of fake it with tuples, but that's still something you have to deconstruct. In Go, you can have multiple return values that are all separate individual entities, not technically related at all. And then for those of you who are around in June, when I did my talk on interfaces, you know that I have, I don't want to say a love of interfaces, but I probably an undying connection to interfaces in the C# world. And I know too much about them. I've actually been correcting some people who are Microsoft MVPs because they're not aware of the changes that actually happened in C#8. So that's fun. But interfaces in C# are something that I know a lot about, and I teach other people on that. I have a Pluralsight course on interfaces. And so the approach that Go takes on interfaces is really kind of interesting. And so again, that's something that I'm going to be looking at. There's a whole bunch of additional topics I'm not going to have time to talk about tonight. And we'll talk about those later. But that's it for slides. Is everyone okay with that? Does anyone want more slides? Okay,
No.
well, we'll just we'll go with this. Because what I want to do is I actually want to spend time in code. That's the way that I learned this. And so that's the way I'm going to show you, because a lot of times I find that the way I learn things help people who are kind of on the same path as I am. So let's show some stuff. Now, what I'm going to do is create a Go program that is going to get data from a web service, and we're going to make multiple calls to the web service and do it concurrently. So this will give us a lot of things to work with. We'll be able to see how the language works. We'll see how to make HTTP calls. We'll see how to do concurrency. We'll see how to do looping and some other things. So the way that I have this set up, and the GitHub repo is set up the same way, is I have two folders. I have an async folder, and this is where we're going to be putting our code. And then I have a .NET people service. And this folder is actually, let's see if I can get the terminology right. It's a .NET 5 ASP.NET Web API service. Is that the correct terminology? And so it's actually a sample service that I use for all of my C# demos, but going to be using it for Go demos tonight. So that's going to be providing us with what we want. So we'll look at the service in just a bit. For now, I've got two terminal windows open. And let me just go over to the .NET service and do folder, I should say, and do a .NET run, fire up that service. We'll take a look at what the service is doing in just a bit. For now, I'm going to go to the async folder. And there's nothing in this folder right now, 0 files. So we're going to start with a brand new project. I'm going to be using VS Code tonight. So I'm going to start by saying code main.go. So a main.go file is kind of how you signal the entry point of your application. If you call your file that, then the compiler will know exactly where to fire things up. And with that, let me just do some rearranging here. So maybe we can see a bunch of things at the same time. Okay, these guys did not attach. Come on, Windows. Okay, I'm going to try that again. Oh. Don't do that to me. Okay, fine, we'll do it manually. Sometimes Windows decides that it's going to attach that little slider, so they're nice and easy enough. Okay, let me make sure this is nice and big. Now, before I start typing anything, you'll notice up in the corner, it's really little, but it says Go up here on my tab. And that's because I have an extension installed. And if you're going to be doing Go programming, get this extension. It's called Go. And what this will do is it'll give you linting, it'll give you formatting, it'll give you like code completion, and even there's some code snippet like behavior that I just discovered and I'm going to be using tonight. So do not try to program Go in Visual Studio without that. Okay, so hello world is where we start, right? Everyone? Yeah? Okay. Feel free to turn on your camera so I'm not just looking at names. Okay, so I'm going to start out with a package main. Okay, so a package in Go is somewhere between an assembly and a namespace. So it's a unit of code. It can cross multiple files. It's not really like an assembly because as we'll see, everything gets compiled into a single executable. So we're not going to have a bunch of DLLs floating around like we normally do. I'll say we have by default in the C# world. So a package main is what you have to use as the entry point to your application. So if you want to create libraries with business logic or whatever in them, you can call your packages whatever you want, but your entry point does need to be in package main, and you do have to have a func main to start things out. Okay,
Jeremy?
so package main.
DRE Web asks, what is lynching?
What is lynching? Did I say
Yes.
lynching? Did I say lynching? Or am I just talking
guess we
really
may have
fast?
misunderstood. Sorry about that.
Okay. What would I have said that sounded like that? I don't know. If anyone thinks of it, help me out. Linking. What is linking? Like C# linking?
I know what linking is.
Linting.
Oh, linting.
Okay, I'll go with linting. Yes, I'm sorry. That is a word I'm familiar with because I did actually say linting.
And you were talking about Visual Studio Code too.
Yeah, so this is part of the Go extension for Visual Studio Code. And linting is basically, it gives you code hints. So it'll say, hey, this is bad. Sometimes it'll say, this is a name you probably shouldn't use. Sometimes it'll give you warnings that say, okay, well, you're doing this thing. You're probably going to regret this. So you might have done it by accident. So I'm going to show you, hey, maybe you want to do this differently. So it's not things that would cause code errors, but it's, or I'd say compiler errors. It won't prevent your code from compiling, but it may cause you pain in the future. So I'm not big in the JavaScript world, but for you JavaScript people, I know there's some of you out there, there's a bunch of linters out there and you run your code through them and they tell you everything that's wrong with your JavaScript. So linting, yes, that's a word I understand. So when we're looking at this func main, a couple things to point out. First of all, you'll notice the opening curly brace is on the same line as the func. That's actually required. If I move it somewhere else, this is going to result in a compiler error. It's going to say, hey, I don't know what you're doing. You can see I've got a red squiggly. And it says unexpected semicolon or new line before the curly brace. So unlike C# and or JavaScript, you must have your opening curly brace on the same line. Otherwise, it's a compiler error. And for the JavaScript folks who have run into that interesting issue where you get stuff returned when you don't expect it, you'll appreciate that. Okay. So to output to the console, I need to bring in another package. I need to import a package, one of the standard Go packages. This is similar to a using statement in the C# world. But I want to point out something about the code extension that frustrated me really badly, because I've been coding C# since the dawn of time. It's a really long time ago now. It wasn't the very beginning, but now it seems close enough. And so often what I would do is I would say, okay, well, let's bring in all our using statements. So I'd say, okay, well, I need to import the FMT package, which is the format package. And so I might add all my usings at the top. These days, I don't bother because Visual Studio kind of auto adds using statements for you amazingly well. Love that kind of stuff. The problem is that watch what happens when I save at this point. My import just went away. And that's because I wasn't using it. And so if you have an import that you're not using, the Go extension deletes it for you automatically. So as someone who likes to type and save frequently, I found this extremely frustrating. The good news is you don't have to type the import. If you just start typing, okay, well, I need something from the FMT package. And in this case, it'll be a print line. And let's save at this point. Now it brings it in. Okay, so generally you don't have to worry about managing the imports manually. But if you feel like you need to import all your packages at the top before you have any code, first time you save, they're all going to go away. It's terrible. Okay, so we'll do a print line, hello world, which will go out to the console. Yay. Okay, one other thing is no semicolons at the end of the lines. So, and that's another thing, as a C# developer, I type them all the time, but if you save, they go away. So that's kind of helpful. And this actually gives us enough to program with. So if I do a listing, I have my main.go file, and we'll do a go build, and that will build me an executable. So now I have something called async.exe. You'll notice it's kind of big. So that's, what is that, 20 megabytes? But that's because it's a fully self-contained executable. So it contains everything that I need. There's no runtime, no anything else. I could put this on any other Windows machine, Windows 10 machine, and it'll run. And this is also cross-platform. You will need, if you have it on Linux, you will need to build for Linux and build for Mac OS. But it's cross-platform, everything's included in the executable, so that's all you need. So if we just say async.exe, bloop, hello world, woohoo, thunderous applause, as I reach down and get my glasses that I dropped. Thank you, Rob, for the mimed thunderous applause. Okay. So that's great. That kind of gets us started. Okay, we've got a little bit of what's going on. Package main function as an entry point, importing another package, but it's not very exciting at this point. Let's go back to our .NET service, and I'm just going to control click on this to open up a web browser. And I get a page not found because I don't have anything at the root endpoint. But I can say /people, and this will give me some data. Let's see how big it is. It's pretty big. So I have a service that returns a collection of person objects in this case, which is ugly JSON. I can also do people/3 for an ID to pull back an individual record. And then I also have one, which is people/IDs. And that will give me all of the ID values for my record set. So this will give me a valid set of IDs. And so this will be the endpoint that we hit first. Okay. This is where things get fun. Okay. So we'll say func, we'll call this get IDs, and we'll take no parameters, but then we'll have some return types. Actually, yeah, int. We'll start with this. Now, things are a little flipped around compared to what we're used to in C#. So in this case, get IDs is the name of our function. The empty parens represent our parameters. In this case, we won't have any parameters. And then after the parameters, we have our return values. And in this case, I'm using what's known as a slice of int. Now, a slice in the Go world is sort of a dynamic array. It's technically a window into a real array, but I'm so not going to go into those details today. So we can think of it as a dynamic array of integer values that are coming back. Okay, let's see if we can get these. Now, to make the service call, I'll get something
Are
from
all arrays dynamic in Go?
all arrays are not dynamic in Go. So you can create an array, give it a specific size. When you do create an array, you have to say, here's how big it is. When you have a slice, you don't necessarily have to have that size ironed out in advance. So and then you can also have a difference between the size of the array and the capacity of the array. So the size meaning the number of items currently in it, and the capacity meaning the number that it can hold. So again, slices are, if you're going to get into Go, you're going to want to dive into those. But if I just have a regular array and I say array with like square brackets 9, then I'm saying I have 9 elements, and those 9 elements exist, whether they're populated or not. So
Does
the comment is
mean that it's a filtered array?
Filtered array, I wouldn't say filtered. It's more like a window. So if I have an array that's this big, I can get a slice, which is, okay, I'm going to take these 3 elements out of my 9 element array. So it's more like a window than a filter. I cannot comment on like Python slicing because I don't know Python. Okay, so this is what we want to get back. Now, because I know the data set, I could technically say, hey, I know I'm going to get 9 elements back. I could hard code all that, but I kind of don't want to. To make the call, we'll get something from the HTTP package, and HTTP has a get. Now, just a warning, adding the imports thing sometimes messes up, and I get frustrated by this because, let me go back. If you just have one import on line 3, you just have the import keyword and then your package name in quotes. If you have multiples, they're enclosed in parentheses, but each one needs to be on its own line. So this is the format it should do. Sometimes the Go extension works, sometimes it doesn't. Generally, once I get from a single one to 2 elements, adding 3rd, 4th, 5th, it seems to work fine. So not every tool is perfect.
Is it a carriage return line feed versus line feed thing? Like, does it work correctly on Mac and Linux?
Well, the thing is, I've actually had it work correctly on different files. So I don't, I was doing another file from scratch, and maybe it was different packages or something, but it worked. And then like an older version of the plugin didn't have this problem. So I'm not exactly sure what's causing it. Okay, let's look at some method signatures here. So our get function takes a string as a parameter, which is a URL, and then it actually has 2 return values. It has a pointer to an HTTP response. The little star means pointer. Yes, there are pointers in Go, so sorry. And then it returns an error. So this is actually returning 2 different values. And what you'll find in Go, and we'll dive deeper into error handling. We'll take error handling in little bits as we go through this, but it's a very common pattern to have a function that returns some kind of data and an error. And if it's returning, more than one return value, the error is at the end of the list. Now, as I mentioned, it's kind of interesting because this isn't a tuple. The response and the error aren't tied together. They're actually separate items that are returned by this function. So let's get this URL in here first, and then we'll figure out what to do with the returns. Okay, so add some quotes. And what's nice is I can just take the values that are coming back from this and create and assign variables at the same time. So I'm going to say resp error, and then I'm going to use a colon equals. And the colon equals is really a variable create and assign. So you can really think of this as var in the C# world. So if I hover over the resp, it's going to tell me, hey, this is a pointer to an HTTP response. And if I hover over the error, it'll say, hey, this is an error. So the types are inferred based on what's coming back from the get function, but they are strongly typed. We can also declare variables separately without assigning to them. In that case, we have to explicitly declare the type, and we'll see that a little bit later. Okay, so what I'm thinking is, since there's this pattern of data error, data error, data error that we'll actually see multiple times, I'm going to want to do the same thing. So let's do data error as my return values from this particular function. So I can follow this same pattern. Now, the interesting thing about errors in Go, they're basically glorified strings. So they don't have the same gravitas as an exception. It's basically a message that said, hey, something went wrong, deal with it how you like, but it's not going to interrupt your processing. It's not going to, break out of a function or anything like that. So it's really hey, there's a problem. If you want to look at it, do something with it. There really isn't an equivalent to an exception in Go. The other thing that we can have is known as a panic. And I love the word panic because it really tells you something really bad just happened. And for example, if you try to read past the end of an array, so if you have a pointer to array, you try to read past the end, in the old days of C and C++, that gets you bad things happen. Well, in Go, that gets you a panic. And as soon as your application panics, there is no rescuing it. Your application will exit. So just so you know that. So there's nothing like an exception that you can catch. There's an error that you can look at and add to and pass along. But it's quite a bit different. And we'll kind of see what that looks like in just a bit. So let's check this
on its way down.
Yes, you can. And actually, we'll show some logging. So I will be showing that. I see something in the comments, no stack then. And the answer is technically no, but kind of yes. And as soon as we see an error message pop out, that'll make a little more sense. Okay, so I'm going to check to see if the error is not equal to nil. So nil is the equivalent of null in the C# world. And you can see my if conditional. The condition does not have any kind of parentheses around it. Opening curly brace, again, on the same line, and the curly braces are required. So unlike C# where you can have optional curly braces if it's a single line, not in the Go world. It has to be there. And a typical pattern that's followed is if you get an error, you short circuit the rest of the function. So in this case, I would say, okay, I'm going to return from here. And in this case, I'll return nil for the data since I don't have valid data, and then pass along the error. Now, to start with, I'll just pass along the error that we get. We'll see how to customize this a little bit later. Okay, so now that I have the error, and I'm like, okay, I don't have an error, I can look at the response. And the response has a body property. And this is really what I'm interested in because this will have my payload. And what's nice is the documentation is pretty good on this when you have the Go extension installed. So you can see this actually scrolls. So there's quite a bit here. So you can find out what this is. Now, in this case, it says it's an io.read closer, which implies some interfaces, which we'll see in a little bit. But what I really want to do is I want to take this payload that I'm getting back, which is, this is technically JSON, even though it's really uninteresting JSON. And I want to turn that into my slice of int that I have here. And I can do that with a JSON decoder. there is a JSON package that again comes with Go. And we can say new decoder, and the new decoder takes an IO reader as a parameter. Now, again, an IO reader, that is an interface type. And one thing that's interesting about interfaces in Go is interfaces are all implicitly implemented. So what that means is for IO reader, actually, I should look at what the details are. Most likely it has a read method as part of the interface. The IO writer has a write method. I've actually looked at that one. So the IO reader probably has a read method on it. If a type has a method with that signature in it, it automatically implements that interface. So you don't have to explicitly declare, hey, this thing's an IO reader. All you have to do is put that read method in there and it magically becomes an IO reader. So that's kind of interesting. Okay, so response.body is a read closer, which is complicated because that actually combines IO reader and IO closer. We'll talk about closer in a little bit. And now that we have this new decoder, we can call the decode method on that. The fun part about this method is if we look at the type, this takes an empty interface as a parameter. So you can see here, I have V, which is the name of my parameter, interface with an empty set of curly braces. So this is an interface with no members. What's interesting is because we have since we have implicit implementation in Go, every type satisfies this interface. So this is very similar to saying object in the C# world. So in C#, everything's an object. So if you use object as a parameter, you can stick whatever you want in there. It's very similar here. We have an empty interface, which means every type that we have is going to satisfy this. And that actually includes a slice of int, for example, which is what I want to populate. Now the parameter that, I'm sorry?
Oh, sorry. JR asks, can multiple statements exist on the same line?
So the answer to that is yes. Multiple statements can be on the same line, separated by semicolons. That's the one place you will use semicolons. And we'll actually see a small example of that a little bit later.
Do the imports need to be alphabetical?
I don't think they do. So I believe that's just what the linter does, similar to C# where you have the little helper that says arrange and sort usings. So it's a cleanliness thing. I don't believe that's enforced at all. In fact, I know it's not because I've had things in different orders on some other projects and they work fine. So the parameter that we stick in here is actually going to be the object we want populated. Okay, so you can think of this as like an out parameter. So I need to somehow figure out how to do that. Okay, so I need this slice of int. One thing that we can do, which is interesting, and I'm not sure if I like this or not, we can name our return values. So I can call this IDs and I can call this for the error. And now this error that I have here is actually the same thing that I have here. And so now I have in my scope a variable called IDs, which is a slice of int. And I can now use this in my code without explicitly declaring it because it was declared by the return type. I'm not sure if I like this or not, but it's actually kind of interesting because at this point, I can pass the IDs to the decode and it will populate that variable that represents the return value. So that's, again, I'm not sure if I like this or not. There's some other implications that I'm probably not going to talk about tonight, but it's fun. Now, there is one other thing that I need to do this. And that is I need to put an ampersand in front of this. So again, pointers, I'm sorry. Pointers, when I was doing C and C++, messed me up all the time. And I was just like, okay, I'll try an asterisk. Did that work? No, try an ampersand. Did that work? It's actually not that bad in Go. The way that I think about this in Go, and because this is the way it behaves, is if we just pass, if we pass a parameter to a method, it's just passed by value by default. So if I were to pass IDs into this decode method, then decode will populate something called IDs in its local scope, but it won't have any impact on this IDs that I have in the outer scope. If I pass in the address using the ampersand, this would be similar to doing either an out parameter or a ref parameter in the C# world, where it will modify this IDs that I have up here on line 9. So it actually has the ability to modify that and the changes stick. What I like about it is you have to be explicit about the things you're allowed to change and the things that are just getting passed by value. And so it took me a little while to get used to it, but kind of once I got into the groove of it, I kind of like, okay, yeah, I get this. I understand this. So we'll decode into this IDs object that we have. Now, decode does also return an error. So we'll just kind of grab that and check to see if there were any decoder errors. Now, you'll notice I got red squigglies here, and that's because if I hover over this, it's going to tell me second line from the bottom, no new variables on the left side of the colon equals. So since error is already declared, I can't redeclare it with the colon equals. So I just have to say equals for assignment to this. Now, what's interesting is on line 10, error is already declared because it's up here in the return type. So that one's already declared, but resp is brand new. So as long as at least one of the variables on the left-hand side are new, the colon equals is fine. Otherwise, if it exists, then we'll need to use equals.
Does it have to be the first one?
No, it doesn't. So it can be whichever one, as long as there's at least one. And again, kind of for simplicity, until we get more into errors, we'll kind of let that go with the same kind of error return. But this error would actually be what's coming back from the decode if there's a problem there. And then we'll return IDs and nil. That would be our happy path. Wow, that seems like a lot of effort. Now, as an example of one thing that the linter does for us is you'll see the yellow squigglies up here. And this is just saying, hey, you know what? Get IDs is declared, but you're not using it. Is this true? Yes. One interesting thing is you'll notice if I make that a capital G, that squiggly goes away. Why is capitalization important? Yeah, it took me a while to wrap my head around this one too. Capitalization determines the visibility of your types and methods. So if it's capitalized, it's actually exported from the package. So you can think of that as public. If it's lowercase, it's internal to the package. It's not visible outside, in this case, of the main package. So capitalization is important in Go. So lowercase is internal to the package. Uppercase is potentially exported from the, or is actually exported from the package. And so that's why you'll see, like on the HTTP GET on line 10, the GET is capitalized because it's exported. On the JSON package, new decoder is capitalized because it's exported. On the format package, println is capitalized because it's exported. So if you're using anything from another package, it will be capitalized because that's the only way to export things from a package. So that's why it's saying, oh, well, if it's internal, you should use it. If it's external, well, maybe some other package is going to use this in the future. Okay, I feel like I'm talking very quickly. Am I talking very quickly?
No.
No, I'm okay. I see people still watching, so that's good. Okay, so let's call this method. And for this, we'll say IDs error set equal to get IDs. And Go is, now I'll show that in just a minute. Let's, okay. Let's skip the error for now and just get these IDs out to the console because I need to see more progress. Okay, so I'm going to say print line IDs. And you'll notice I have a red squiggly, but let's just build this and see what happens. Go build, and I actually get an error. So it says, hey, on line 22, error is declared but not used. So in Go, you cannot have unused variables. It's actually a compiler error. Now, if you want to get around this, the underscore works great. So as a blank identifier, if I do a build again, build is successful. So similar to the underscore in C# where we're saying, hey, this is a discard, that works in Go as well. So I'm being explicit about, hey, I don't want this. Let's run this and see what happens. Fingers crossed. Data. Wow, very exciting. Okay. But we are actually getting data from a web service in 25 lines of code. So that's kind of cool. You can actually build a web service in about 40 lines of code. But I'm not going to show that right now. Okay. Well, let's see what happens. We'll get a little more into error handling. So I'm going to stop the service and run this again without recompiling. And what happens is I get a set of empty brackets. So what's happening is, I'm hitting this error block. So it's returning nil and error down here to line 22. So IDs is nil at this point. And it says, oh, I have no problem printing a nil. So since it's, again, a slice, a dynamic array, it's going to just print out a set of empty brackets. Say, hey, there's nothing in your slice. We should probably do something a little different. So let's grab this error. Oop, too far. And check it. So we'll say if error not equal to nil, yes, we will see this pattern over and over and over again. FMT printf. Now printf is a formatted print statement that works similar to string.format. So the idea is that we create strings that have various verbs in them. And the verbs are placeholders. So in C# we're used to using like the little curly braces to mark our placeholders for a string.format. In Go, the verbs are, they're done with percentages. So let's give a little message, get IDs failed. And we'll do a %v and print out the error. Now, if you're curious about these verbs, a %v prints out something in its natural format. You can think of that as a toString, so kind of a default toString. But unlike C#, the default toString in C# will basically give you the type, fully qualified type name. Generally not useful. In Go, the default will give you the elements. So if I have a struct with some fields in it, it'll give me the data in a format that's not real pretty, but usable. Now, if I want to look something up, for example, from the format package, I would say golang fmt. You can see my browser remembers this because I do it quite a bit. And that will bring you up to the documentation. So golang.org, and then there's a PKG, and then pages for each of the packages. And the FMT package right at the top has a listing of all of the verbs. So again, kind of numbers and strings and significant digits and all kinds of other things. So the documentation, pretty helpful on this. Okay, so with this in place, let's say
When
go
you moused
build.
over a function, it popped up similar documentation. Did that come straight from that site?
When I did like this,
Yes.
this I believe actually comes from the source code.
Oh, cool.
So
Is there a way that I
uh,
can decorate
can
my
I?
methods to export similar details?
Yes, there is. You do something like this. So if you put comments and comments, / comments, so C style comments above your functions, they get pulled in. And that's something that works. I've actually tried it. It's kind of interesting. The other thing that's interesting is you'll notice I'm in the source code of the print.go file. So this is the source code for printf, which is interesting. Oh, it uses an fprintf internally. That's interesting. But yeah, so it actually comes from there. So you can code in Go without an internet connection, as long as you're using the standard packages or the things that you've built yourself. As soon as you need to do like a third-party thing, kind of like a NuGet-ish kind of thing, you'll have to be connected to the internet to bring that down to your machine. But once it's on your machine, you can use it without an internet connection. Okay, so let's run this. Fingers crossed. And now we get an error message. No, cancel. And so there was a question about the call stack before, and we kind of get a pseudo call stack from the error messages. So you'll see what I did was I prepended my message, get IDs failed, with a colon, and then I said, okay, give me the rest of the error that's coming in. So that's this first part. And then I got okay, here's the get call to this address. And it's actually trying to do localhost on this port, and then connect X, and then no connection could be made because the target machine actively refused it. So even though it's not a call stack per se, we basically have a list of where this error originated, and hopefully kind of works its way up. Now, something I always forget to do on a %f is I forget to add a new line. So I'll add a new line, go build, and then run this again. Because I want to show that this, the empty brackets are still here, and that's because I'm not doing anything to exit out of the program. It's just continuing on to line 26. Now, I could do a return here, which would exit out of the main function. But something that would be a little more useful is actually from the OS package. And OS has an exit method that we can call. And if I pass in a non-zero value, that is an error code. And so for anyone who's done console application programming and tried to figure out, hey, did this console application complete successfully or did it fail? You're familiar with checking for error codes when something exits. And so that's actually how we do it in Go. Let's do a Go build to bring that in. And this time what we'll see is we don't have that empty square brackets at the bottom because it's short-circuited and we're exiting out of this thing. Now, format.printf has a companion from the log package. So if I change fmt to log, there is a log.printf, and you might have seen my code all bumped down. That's because it added the log package to my imports. And if we build again, then what log does is it prepends the message with a date timestamp. Very useful. The other thing is that log can be redirected. So by default, format.println goes to standard out, which in this case is my console. By default, log.printf goes to standard out, which is my console. But I could point my logs somewhere else, and I'm not going to show that tonight. Now, since kind of doing these two lines together, 26 and 27, log an error, exit out of the program with an error code, is kind of a common thing to do. There's another log function that combines these, and it's called fatal f. And so this is I'm logging a fatal item. So it's going to both log and exit out of the application with an error code. So just, I kind of like this. There's like, I keep finding little pieces that make this intriguing and interesting. And if I save this and do a go build and async again, I'll get the same results because we haven't changed the way it operates. We've just combined the logging and the exiting into one thing. Oh, wow. Okay, I'm going to do one more thing. As long as
There's
we're
a
talking
question
about,
that says you're able to jump straight into the format function. Is there a way that I can obfuscate my code so that others can't do that?
no. So I'll show you an example. So I use the let's do it this way. I brought down a package which is gorilla/mux, and it's a way to get parameters off of a URL really easily. So I probably will not have time to show that tonight. But when you get a package down, like for example, let's say, might as well go through this whole thing. Okay, github.com/gorilla/mux. Okay. So this will tell you how to use it. It's a package for router and dispatching. So it's actually pretty interesting. And the way that you install these is with a go get command. And so this will install it on your local machine. Once you have it on your local machine, it goes into the default installation location for Go, the Go path. And this is in your user folder, C users Jeremy or Jerem on Windows. And if I cd into Go and take a look in there, I have a bin, a package, and a source. If I go to source and look at that, I have some things from GitHub. Let me make that a little bigger. Golang.org and Jeremy Bytes. That's stuff I built myself and put in here so that my other programs could find it. So if I say cd GitHub and look in here, I'll see Gorilla is in there. Gorilla and Mux. And this is the repo. So it basically brought the repo from GitHub down to my local machine. And when you compile a Go application, it compiles all the source code together. So if you're making public packages, they're public. So that's kind of how it works. If there is an obfuscatorial way of doing that, I might have just made that word up. I'm not aware of it. With the way that everything is just publicly open sourced everything now, I would guess that it's probably frowned upon in the Go community, but there may be a way of doing that. I wouldn't count it out entirely.
Let's go libraries. Once I end up with async.exe, is there a way to reflect through that and get back to the code?
In this case, it's a Windows executable. So anything you can do with a Windows executable, you can do with that. I mean, it'd be no different than decompiling a C program. It's there. I've actually done, so I've done a lot of work with reflection in C# and taught people how to use it. And one thing, once you show people how reflection works, they're like, oh, that means that none of my stuff is secret. And I'm like, that is correct. But in other environments, nothing is secret either. If you have Java applications, you can decompile them. If you have C applications, you can decompile them. So if it's on your machine, you might as well just expect somebody to have it. So if you really do have true secrets, keep it on your own machines. You know, it's no different than a lot of other things. Can you call a C++ DLL from Go? I'm pretty sure you can, but I have not done that. I would be very surprised if you cannot. Just in case you're curious, this is what I've used for learning the Go programming language by Donovan and Kernighan. And yes, it is that Kernighan from the K&R, Kernighan. And this book has been helpful. I haven't actually read the whole thing. So that's how much of not an expert I am. I haven't even read the entire book. But how far did I get? See, the problem is I got to a certain point and I'm like, oh, I just need to play with this. Okay, apparently I got to chapter 9 and my bookmark is a 1,000 kroner note from Iceland. So, anyway. Did that answer the questions? I got way off track. So
yeah, that was perfect. Thank you.
okay, cool. Cancel. Okay, so let's head back here. Now, talking about errors, let me do some custom error messages before moving on, and then we'll grab the rest of our data. So the format package also has an error F function. You might be seeing a pattern. So we've seen printf, fatal F, error F. So these are things that all the things that end with F are things that have a formatted string, basically, that have those verbs in it. These generally also do have, I guess error F doesn't, but fatal, for example, has one without the F, which you can just basically pass it an object or a string, but you can't use the placeholders. But anything that has the F at the end is formatable. And then you'll also see, we'll see a little bit later, there's also an sprintf. So printf goes to the console, sprintf creates a string, fprintf creates goes to a file, or technically anything that implements the IO writer interface. So this is fun. Let's see, HTTP get call failed. That's the message I'm going to stick in here. And we'll do a %v and error. And then down here, fmt errorf, and we'll say parsing JSON failed. And let's see, okay, we'll keep our service stopped so we keep getting errors, do a build again. And now we'll actually kind of see our custom message added to the call stack. So here's our logging timestamp. Here's the get IDs failed that was added down here, line 25. And then this HTTP get call failed was added on line 13, the thing we just added. So you can see it kind of builds a call stack ish in the error messages. Now, some interesting things that the linter will do to help you out is if I really, it's not going to do this right now. So inconsistent. Let me try again. \n save. There we go. Okay, so if I put a new line at the end of my error statement, it's going to say, don't do that. Error string shouldn't end with punctuation or a new line, because we're expecting this is going to get passed to someone else. They're going to append to it, prepend to it, prepend, prepend, prepend. So don't be sticking new lines in the middle of this, or punctuation. So if I do a period, I believe I'll get that same message, yeah. The other thing is, let's try the, yeah, okay. It'll say error string should not be capitalized. So there's kind of a lot of things in here. It's opinionated about how you create your error strings. And again, it's because this isn't the beginning of something. Something else might be prepended to it. So capitalization is not appropriate here. So Go has a lot of opinions about things. Now, again, those were yellow squigglies. They will not stop me from compiling, but it's basically saying, hey, you know what? You're doing this differently from the way everybody else does it. So, get in line if you want to be accepted. Okay, let's move on. So let's start up the .NET service again. And I don't know if I need to rebuild, but I will. And just make sure this is still working. Okay, great. After an hour, we should have more than this, right? It actually goes faster from here. Okay, except I need to cough. Let me find my cough button. Okay, and my uncough button. Okay, so the next thing I want to do is I want to loop through the values of my service. So I'm not going to get the full collection because, again, I want to show how concurrency works. So instead of getting the whole list, I'm going to get them one at a time. Now, the thing about this particular service is I have an artificial delay built into it. So each time I ask for an individual record by ID, it pauses for 1 second. Now, I did that so that when we get concurrency going, we can actually see that happening. In the meantime, it's going to be a little annoying because it'll take 9 seconds to get all 9 of our records back. But let's do that. Now, for this, I'm going to use a for loop. And I want to for over the items in the ID. Now, something that I discovered today, and this might just be because the extension keeps getting updated, is if you notice on the little pop-up that I get, there's this box next to the for, and then on the right, it says for statement. This is a code snippet. And so if I hit tab here, except I did that badly. Let me do that again because I fat fingered it. It's going to create a for statement for me with the indexer and everything. I love this because I'm a lazy developer. And I won't ask who's a lazy developer in the room because the joke doesn't work over Zoom. And so in this case, I can do, for I equals 0 to len of IDs, I++, and I'm just tabbing through it. And then once I get to the body, kind of that little template thing goes away. Len is a built-in length function in Go. And so this will give me, how many items are in this IDs slice. Now, there was a question about multiple statements before. And here's an example of using multiple statements on a single line, which is the I set equal to 0, semicolon, I less than this, conditional, semicolon, I++, another one. So we actually have 3 statements that are all on one line. So you can do that with the semicolon. Otherwise, semicolons, again, at the end of the line, if you save, they go away. So, excuse me. Okay, so usually what comes up is when I show a for loop, it's like, well, what about a for each loop? Because I'm a C# programmer and for each is awesome. And I love for each. That's a personal thing. I'm not dissing it at all. I love for each. Can you do that? And the answer is Go only has a for loop, but you can do a for each. What about while? Well, Go only has a for loop, but you can do a while with it. What about a do while? Well, Go only has a for loop, but you can do that as well. So I have an entire article. If you go to the resources, let me go to the resources. So I'm going to get there the lazy way. I'm going to go to my website and then click on the link. So here we are, a tour of Go. And then there's a GitHub repo. And then if I scroll down, there's a bunch of articles. One of them is about loops, a unified for. So even though Go only has a for, you can change the conditionals to do the same thing as a for each, a while, endless loops, do whiles, etc. So this article actually shows all of that fun stuff if you're interested. I'll show a couple things later, which is kind of cool. Okay, so let's call this, where'd my, oh, Oh, I haven't called that method yet. Oh, well, that's not very helpful. So I need to call a method that I haven't written yet. So let's write that right now. Because basically I need this same thing that will get me the person object rather than the IDs. Okay, func get person. And this will actually take a parameter, which is of type integer, and we'll return a type I need to create and an error. And when we're declaring parameters in Go, they're flipped to how we're used to in C#. So the name comes first and the type comes second. Now I need this person object, and I'm just going to comment out this block of code because I don't want Go screaming at me while I do this. Oh, it deleted it. That was good. Because I want a type that will be able to accept this JSON object. So I want to deserialize into this. So I'm going to create a struct that has the fields that I care about in it. So we'll say type person, we'll call it person, and this will be a struct. And then I'll put my types or put my fields in here. Now you notice I lowercase the person, so this will only be used internally. If I wanted, again, to set up a library to make this externally visible, just capitalize that, it'll be exported. And so I'll go through some fields. So we'll say ID, which is an integer, a, what's the order here? Family name, which is a string, a given name, which is a string, a start date, which is a time.time, and a rating, which is an integer. Now, something that is interesting, watch what happens when I save this file. Boop. It lined up the types. So it's a curiosity, but that's something that, again, the extension does for you. Now, one thing is you'll notice that these field names are capitalized. And the reason for this is I found that if they're not capitalized, the JSON deserializer can't find them and put stuff in them. So even though this person type is internal, these the fields themselves have to be public-ish so that the JSON decoder can stick things into them. Oh, that took me a long time. Oh, and then opinionated. Here's another one. Why aren't you screaming at me? Oh, that used to scream at me when I did uppercase I, lowercase d for ID. Maybe it got over that. Okay. So we're going to be doing something pretty similar to what we did up here. I'm not going to do copy paste because that needs to be gets. Because right here is where things will change. So I have my URL, but I need to parameterize it. So on line 24, this 3, I want that to be the ID that's coming in. Now I could do some kind of inline string format stuff here, but it looks really ugly. So I'm going to instead just create another variable to hold this. So we'll say URL set equal to fmt.sprintf. And then we'll put that in. We'll change this to a %d instead of a 3 and pass in the ID. So sprintf will give us back a formatted string. So now URL will hold that, and I can put that in there. I could technically put this entire thing into the parameter, but really ugly. So that's why I have this separate one out here.
Is there value of format.sprintf over just doing a this string plus that string?
I have not tried that, and I do not know. I have not actually seen in any of the examples I've looked at, I haven't seen concatenating strings. I've seen using the format functions. So I'm actually not sure if concatenation works. I'm going to try that later. there's probably a string concat method that you have to use.
Do it.
Okay. I'm not going to do it right now. I have too much to show you. I don't want to keep you here all night. As soon as I get this part through, though, it goes really fast. I will do a little copy paste here because some of this is similar. Paste. Okay. So let's just change this message to error fetching person ID %d, and then we'll pass in the ID and the error. Now you'll notice it doesn't like me passing back a nil for this person, and that's because this is a struct. So what you can do instead is pass back an empty person object. So this is a person struct that has none of the fields populated, basically. The fields are there, but they're all 0 values. And then in order to do the deserialization, I'll create a separate variable. So if I want to declare a variable separately, the var keyword, the name, and then the type, and then I could use the ampersand p to decode it into, so just like we were decoding before. And then here we'll say person. And then happy path, return p nil. Now there is actually one thing that I forgot, which is kind of important and not important at the same time. Well, it's important. In our little program, probably doesn't make a difference. In a big program, it does. Let me go to back to this resp.body. And whenever I demo this, I always forget this step. So this isn't out of the ordinary. I noted that this is an IO read closer. And so we looked at the IO reader functionality before, but now we kind of need to look at the IO closer functionality. And let me just scroll down here a little bit. Where is the magic phrase? Nil, blah, blah, blah. Oh, here we go. Okay, this magic phrase right here. It is the caller's responsibility to close body. So we can think of this as similar to an iDisposable in the C# world. So we want to dispose of it when we're done. In this case, we want to call close on it. And so if I'm kind of going through here, I'd say, okay, well, you know what? If I get an error here, I'm going to want to say resp.body.close. And then down here, I want to do resp.body.close. And so kind of thinking about where are my exit points? Well, I don't like this, right? In the C# world, I would use like a finally block. So whether you get the error path or the happy path, you're going to do this thing. Go has something similar that I think is so much cooler, and that is the defer keyword. And so up here, I can say defer resp.body.close. And regardless of what exit path this function takes, this will be called at the end of it. I think that is so cool. The reason I like this better than finally is because when you have a finally block, it's at the bottom, right, of whatever block you have. This defer can go anywhere in my function as long as, in this case, you know, this resp.body exists. So after we check the error from this. And what that means is I can put it close to where I'm thinking about it. And I don't have to say, oh, I need to do this at the end. So defer, I think, is really cool. And I should be doing it up here as well. So we'll stick a defer resp.body.close in here as well. Now I am going to do
it before line 28.
Actually, I can't. So if I move this up, I'm going to get a squiggly that says, using RESP before checking for errors is not a good idea. So it's actually saying you should do this after you check for errors. So that's why it's down below there. And theoretically, if this get does return an error, then this RESP will not be populated. So, not really worried about that. Now, another interesting case that I need to worry about here is what if somebody passes an ID that's not valid? Well, what my service does is it returns a 204 no content. And this will not catch that. So I don't have anything that's catching that, but I can look for the status directly. So make sure I get this part right. Yeah, resp.status code. And so I can say if it's not a 200, then I want you to return an error. So return person, empty person, error f, and we'll say error fetching URL, pass you the URL, return status code %d, and then we'll pass in the URL and get the status code back. And that makes for a kind of big line that I have here. But the error message will contain the URL that I'm trying to reach and the status code that's coming back.
Ooh, oops, I missed this question a bit ago. Are strings immutable?
Jeepers. I should know that. I don't know. Based on what every other programming language that's kind of in a similar category is, I would assume yes, but I'm not going to make any bets on that. So can you continue a line? That I'm actually not sure about. Will this build? We'll try it. Okay, so this built. Let me just. Okay, so one thing that, again, kind of the extension does is it gets your indents in the right spot. So if I save this, it'll say, oh, well, this belongs with the previous line. So the answer to that is yes, you can. So the question is, there's a question that says, can you syntactically exclude the curly braces on an if statement? And the answer is no. Curly braces are always required. There's no options on that. So even if you have one statement, you still need the curly braces around it. Okay. Yeah. Let's call this, do something interesting. P error. Set equal to
Really long lines. Can you wrap text to the next line?
That's what I just did. For this one. Come on. This is the one line of code that I really hate in my sample because it's really long. So for this, I went like this and hey, let's just try this and save. So it looks like Go is perfectly okay with that as long as the indents are there. Now, without starting a culture war, I am going to point out one other thing. I don't know if this will show up on the Zoom, but if you highlight the white space before these lines, they're tab characters. So spaces versus tabs, they're tab characters. So yeah, that's all I'm going to say about that.
You say it in hushed tones.
Hushed tones, then nobody will yell at me. Okay. I'm going to ignore the error for the moment and then get something to the console because I feel like I haven't written anything new to the console for a really long time. FMT printf, and we will say ID. Oh, no, I'll go %d colon %v, and we'll say p.id, come on, ID and P. Ah, and I'm going to stick a new line in. I always forget to stick in new lines. So what this will do is it'll pull the ID property the ID field off the person and then print the person in the natural format. Okay, come on, go build. Oh, look at that. Actual data coming back. So one thing this shows us is it shows us what the %v gives us for the default format. And in this case, it's just printing out the values of, of all of the fields. There is, let's see, there is also a +v. Let's see if I got this right, or if I'm just gonna, yeah. Oh, look at that. Now, if you do +v, it prints out both the, wait for it to finish, the property or the field name and the value. So this is the default format with both of those. Now, I think both of those are really bad for this application. I would like to change the default format. Now, in C#, we would think about, okay, I want to override the toString property. But there really isn't that same thing in Go. However, there's an interface for this, and this is in the format package as well, FMT. I'm going to look at the stringer interface. Make that a little bit bigger. Woo! Okay. So this stringer interface, it's an interface type that has one method in it, which is called string, and it returns a string. So it's not very exciting as an interface, but let's implement this interface on the person object. And again, it's all implicit implementation. So I'm not going to say stringer anywhere in my code. Instead, I'm going to create a func, which is called string, that returns a string like that, because that is the signature. This is the signature that I need. But now I need to associate it with the person type. And for this, we use something that's called a method receiver. And between the func keyword and the name of the function, set of parentheses, p person. So what I'm doing is I'm taking the string function and associating it with the person type. And now this p that we have here is a variable that I can use inside this function. So return format sprintf, and we'll do a %s, and p dot family name, p dot given name, p dot family name. So you can see by having this named variable here, I have access to the object I'm operating on. Now, all I did was add this string method to the person type. Again, I didn't declare it and say, this is a stringer interface or anything like that. This implements stringer. And if I do a build and run at this point, now I have my custom output. I think this is really cool. And it's very interesting from the perspective of, again, someone like me who deals with interfaces and some of the complexities. So the interface basically says, we don't care what you call yourself as long as you have this shape. So if you have this shape, we're fine. If you have a string method, that's all we care about. And there's something like deeply pleasing to me about that, particularly as I work on my third revision of the C# interfaces course for Pluralsight. Oh, that's fun. Okay. How much more time do you want to give me? Anyone? Is anyone bored yet?
They don't kick us out of the building, so let's go.
Because I'm babbling way too excitedly. But what I wanted to do, let me I'm going to do a little bit more error handling because I'm not comfortable leaving this like this. So if error is not equal to nil, then we'll do some logging. So we will log printf %d %v \n. Oop, get some quotes in there. And so if we get an error, so this is the get person returns an error. So one of the records errors, then we'll say, okay, here's the ID I was trying to get to, and then here's the error that I got out. And then to generate an error, I'm going to change this to ×2. So get person, I'm going to take my ID ×2. So that means some of my values will be valid and some of them will not. So let's see how this behaves. Okay, so 2, 4, 6, 8, those work fine, but then we have some problems. So in this case, the 5, which is, this is what's coming in from the error message. It says error fetching URL, and it gives us the URL, which has a 10 in it, because again, on line 64, I'm doing this ×2, and return status code 204. So we're actually hitting this error message that we specified before on line 33. So I'm kind of forcing, hey, here's some invalid values. Now there's some other interesting things because you'll see these zeros with the colon. Well, this is the print that we have on line 68. So it's printing out the empty item. I don't want to do that. Now our loops do have continues and breaks, just like in C#. So I can say, hey, if you get an error, continue to the next iteration of this loop. And if we build and run again, we'll get the same errors that are coming out, but we won't have these empty records that are printing. Okay, so again, loops, just like C#, we've got continue and break, so we can short circuit either the current iteration or all the way through. Let's play with this for loop a little bit more, because this is a pretty common thing that we do. We say I = 0 to length of something. Well, Go set up a different way of doing this, which is range of IDs. So now we have I = range of IDs. Now this is still an index, so it's still going to index through. Let me get rid of this error. And so this is going to loop through 0, 1, 2, 3, 4, the indexes of the IDs, but it will still work the same way. So I don't know if you trust me yet. I'm going to keep running this. So this is one way of doing it. Another thing that's kind of cool about the range is we can get a second value out of it, which is the actual item. So let me do a little renaming. The first one is the index. So again, 0, 1, 2, 3. And then the second value is the actual value. So similar to a for each. So instead of having to index back into the loop to get or index into the array to get what we want, we can say, hey, I've got that item. It's called ID. So again, just like a for each, it gives us the item rather than an indexer. Technically, this gives us both. Now, again, I have a, hey, you're not using index anymore. Putting a discard here works just fine for that. And
when we had the old for I = blah, could we have
yeah.
changed the name I to something else?
Yes. So that's just a variable name. And it's I : = 0. So just like declaring any other variable, I could name it index if I'd like. I is kind of the traditional indexer for loops, but you can call it whatever you want. The main reason I change it to index is because for whatever reason, people like kind of single character names in Go. I'm not a fan of it. So often you'll see this written as I, n range of IDs, where I is the index and n is the, I don't know what n stands for. It's the actual item. And the problem is when I'm trying to do, show, hey, what is this? Well, this is an integer. Well, in this case, this one is also an integer, so it's hard to tell them apart. So that's why I'm a little more explicit. And I said, index and ID so that you can kind of see that pattern. But you can name them whatever you like. Okay, now this is great, but it takes 9 seconds. And the concurrency stuff is really cool. And that's really what I want to show you. To get an idea of how long this takes, let's just add a timing. So we'll say start equals time.now. And then down at the bottom, we'll say elapsed equals time.since start. And that will give us a duration object, which is an interesting type. So this is of type time.duration. So kind of similar to a time span in the C# world. And then we can print this out, printf, and we'll say total time, set v elapsed. Okay, and go build.
Oh, it looks like I got that question wrong. It wasn't, can I rename the I variable, but rather, can I start I at a different number? Like, could I have started at 5 instead of at 0?
Yes, absolutely. So it just like a for loop in the C# world, you could say I equals 5 to whatever. You could actually say I equals 5, I greater than 0, I minus minus, right? So you can run the loop backwards if you want. So you can definitely do that. You can change your incrementer so that instead of doing a plus plus, it does a plus equals 2, although you'll need to kind of, it'll be a little longer. But yes, you can definitely do that.
Did I correctly distract the
question
user
is-
so they didn't notice it took 9 seconds?
I'm sorry, what was that, Rob?
Did I correctly distract the user so they didn't notice it took 9 seconds?
Yes, perfectly. Thank you. But you can
So-
see it says 9 seconds down at the bottom.
So the question is, can I change the value of I within the loop so that I would, if it's like, let's say it's a 3, I want to change it to a 6
Yes,
and
absolutely.
skip a few.
So this format, I'm going to point you to the article that I wrote. Do I still have that up? Because that would be awesome. Yes. And this is really little. Let me make it bigger. So, you know, this is kind of the traditional for loop where we have kind of the 3 statements together, but we could also do some interesting, like a while, for example. So while command not equal to stop, you know, and then you set it this way in a while loop. So you can do things like that. In this case, here's a infinite loop while true that has no condition in the case of go, and you have a break somewhere in the middle. I is just a variable. It's an index variable, which you don't want to capture, which we'll see in a bit, but you can definitely change it inside the body. And it is, well, we used it inside the body, so you saw that it was accessible. But we could definitely say I equals 7 in the middle if we wanted to, which wouldn't be very useful in a loop, but you can be creative. So yes, you can, the for loop, extremely flexible. When I first saw, oh, well, there's only a 4, I'm like, oh, well, that's kind of bad. But then it's like, oh, and the condition can be one of these 8 different things, and then you can do all this stuff in the body. It's like, oh, well, okay, it has the same functionality as all these other separate things that we have in the C# world.
But when you're doing range, it's expecting to go through every single one. And can you kind of make it skip some when you're using range?
No, not in this case, because this really is a for each. So it's just like a for each. It's going to say, you know what, here's your first ID, here's your second ID, here's your third ID, here's your fourth one. So range really is start to finish. So if you do need to skip, then you're going to want to use the for I equals, you know, 0 to length, and then you know, take more control over it. Range is really start to end.
Does that mean we can do it asynchronous?
Yeah, the loop asynchronous, or the things inside the loop asynchronous?
The things inside, can they be asynchronous?
Yes, and I'm actually going to show that.
Oh, cool.
Because that's where I'm trying. That's where I would like to get to, because that's when things get kind of really awesome. Because again, this takes 9 seconds, if I can somehow run all of these at the same time, it'll take 1 second-ish. And so that's where I want to get to. Now, I want to basically run this get person concurrently. And in this case, in the world of Go, what I want to do is create a Go routine. That's how important they are. To actually kick something off asynchronously, you use the keyword Go. So it's the name of the language. That's how important concurrency is in Go. But unlike task, so if I think about, okay, well, this get person, if I wanted to do this with a task, I would fire off the task, and then when it's complete, the task has a result property I could get to so that I can get this, p error value out. Well, Go doesn't have things like that. So the idea is, what do I do if I need to return something from something I want to do asynchronously? Well, I don't think about returning it. Instead is I think about putting it onto a channel. Now, a channel is it's really a concurrent queue. So it's a thread safe queue. And the idea is that I can have multiple processes putting things onto this queue. I can have multiple processes that are pulling things off of this queue. And when I say processes, I mean inside the application, that's little p process, not big P process. So think about concurrent processes that are within the application. They can all access this queue in a thread safe manner. So we don't have to worry about threading things. So really what I want to do is I want to run a function asynchronously that will put something onto the channel. And then I have another process that will be pulling items off of the channel. And then in this case, outputting them to the console. To kind of keep things understandable, I'm going to start with a separate method, or a separate function, I should say, but really I'm going to head towards inlining this. So let's create a func, and I don't have a good name for this, so it's going to be called get person to channel. I hate that name, but that's okay because it's going to go away eventually. So this will take an integer ID as well as a channel as a parameter. Okay. Do you like this type? This is a cool type, isn't it? Okay, what does this mean? Excuse me. Well, ch, that's the name of my parameter. Channel is the type, and channels can only hold one type inside of them. So they're strongly typed. In this case, I have a channel that can hold person objects. Let me get rid of this little arrow for the time being. So this would declare a channel that can hold person objects that is a parameter for this particular function. Now, if I put this little skinny arrow, what I'm indicating is this function is only allowed to put things onto the channel. It's not allowed to pull things off of the channel. Now, if I didn't have that in there, I could do either one, and functionally putting things onto the channel would still work. But if I add this and I'm telling this function explicitly, I'm only going to be putting things onto the channel, the compiler can do some optimizations. So if I can specify a direction, it's great that I can do that. Okay, now I'm going to steal the code that I have down here and put it into this function. And so what we'll do is the same type of thing. So I'm going to call the getPerson method not asynchronously, but within this function. And then instead of having a continue, I'll have a return. Since this isn't inside a loop, it's just a single function. And then at the bottom, instead of returning p, I'm going to put it onto the channel. And the way we do that is we say ch, we use the skinny arrow and the p. So I'm taking the p and I'm putting it onto the channel. That's it. That's how I put something onto a channel. Okay.
Why did you choose not to return the error, but rather just log it?
Well, I couldn't put the error onto the channel because the channel holds persons. I could theoretically have a separate error channel that would take care of those, but I'm trying to think of the functionality that I had before. So I'm not changing the functionality. If you have one that you can't find, go ahead and print an error to the log. So I'm doing this without changing the functionality. Does that make sense? Okay, so the other thing I'm going to do is I'm going to duplicate this for loop. And this is going to look weird until I fix it. So in this first part, I'm going to call get person to channel and pass in the ID, and I need a channel as well. So this is a bit odd. There is a built-in make function, and this is used to create, I'll say, more complex objects in Go. So you can use it to create channels. You can use it to create slices, which again are dynamic arrays. And you can use it to create maps. And a map is similar to a dictionary in the C# world. So in this case, I'll say a channel of person, and I'll give it a built-in, I'll give it a size of, or I'll say a capacity of 10. Now, the reason capacity is important is if I leave this out, then a channel will only hold one item. So that means that if I try to put in multiple items onto a channel and it's already full, those are going to block in queue and wait for the channel to become available. So it's going to block until something reads a value off of the channel. If I say 10, I'm basically chunking and say, okay, my channel can hold 10 items. As soon as it's filled up with 10 items, it's going to block until some of those get read off the other end. But in this case, I've got 9 items, so this will hold my entire thing. It gets really complicated once you start chunking big sets of data, which is why we're using a small set of data. Okay, so now I have this function call that's getting a person to channel, and it's going to take an ID and put it onto the channel. Down here, I'm going to pull something off of the channel. So I'm going to use the, I'm going to create a variable type called P, and then set it equal to the little arrow coming off of the channel. Do you like the syntax? So to put things onto the channel, we point our object to the channel. To get things off of the channel, we point away from the channel. So that's how that works. Now this ID isn't happy because we're not using it. I could do a double underscore, but now it's really not happy because it's saying you're not assigning anything. Another thing we can do with a for loop is I can just say for range of IDs. And what this will do is it'll just run this loop 9 times since our IDs has 9 items in it. This is not a great solution. I'm going to fix this, but it'll get us started. Okay, now I haven't done anything asynchronous at this point. All I've done is I've added the channels. So, and actually I've made the application worse because if I run the application, what's going to happen is we get our IDs and then we sit here and nothing happens at all for 9 seconds. And then we get our data. Because again, running things synchronously, what's happening is this is calling this function, which calls this function, which takes a second to return, and then putting something onto the channel. So, and then we're not actually pulling things off of the channel until all 9 items are put onto it. So that's why we messed that up. Now, the reason I wanted to show that is because I want to show making it asynchronous, which again is adding the go keyword. And now we have an asynchronous, or I'll say concurrent functions. So let's do a go build /async and ta-da. Now that is thunderous applause, right? So it took 1 second to complete. Let's run this a couple times. Bloop, bloop, bloop. Now, as with everything concurrent, the fun thing is now the order becomes non-deterministic. Yay. So if you've done concurrent programming, you'll notice these are coming out in, I'll say a non-deterministic order. We are getting all 9 items, but they're not coming out the same each time. And that's perfectly okay for what we're doing. Because
what happens if we change our channel size from 10 to 3?
Then the way things are set up now, we'd end up blocking and hanging the application. So, well, fine.
Makes sense because we don't start draining it until we finish filling it.
Let's see. I might have lied on that. Hang on. Okay, I did lie on that. Because, okay, why? So if it has a size of 3, okay, here's the thing that's interesting. So this function that's putting things onto the channel will run 9 times concurrently. When it gets to line 62, the first 3 will get their values in and then have to stop. So the other 6 ones are still running, but they're stopped on line 62. Now this loop, line 76, the for loop, that completes because that's just kicking off 9 things asynchronously. When it gets down here, it's on line 81, as soon as we start pulling things off of the channel. So if I pull 1 item off the channel, then number 4 that was waiting to put something on will put something on. So in this particular application, we don't see a lot in the differences with the way that it works. When we have errors, it gets more interesting, which is why I left this at 10. So
That makes sense. Is it possible to get a race condition where I try to read the data off the channel before it gets written on?
no, because line 81 is a blocking operation. So there's another thing, which is closing the channel, which we haven't done yet. When you close a channel, then the reads will stop blocking. So line 81, if I put no items onto a channel, line 81 will block. And it'll wait for something to be put onto the channel before it continues. If the channel is empty and not closed, then, well, let me show you how that works. This is fun because there's another way that we can do line 80 and 81, because we can actually say P set equal to range of channel. So we can say, keep pulling things off of the channel. Rob is very excited about that. Keep pulling things off of the channel until the channel is closed. Okay, and that's where things kind of fall over, because let's watch what happens with our current setup. So this worked. Why did that work?
What closed it?
Oh, nothing. You notice this big black dot up here? I didn't save. Let me save and do that again, because it totally should not do that. Go build. I knew I would do that at least once tonight. Okay, now if you notice, my application has not completed. The total time is not showing. In fact, line 80 will block until the channel is closed. Now, it is good practice to close a channel once you're done writing to it, and then any reads coming off of that will just drain the channel. So if there's still stuff in it, it'll keep reading from it. But then as soon as it's empty, then it'll say, hey, I'm not waiting anymore. And so in this case, line 80 is waiting because it doesn't know how many items are on the channel. When I had the for loop on the range of IDs, it was working because I was iterating the same number of times. So that was a cheat. But I want to fix this. And we can actually fix this. To close a channel, it's like close CH is what I would do. So I'm tempted to do something like this and say, okay, well, after this for loop, I close the channel and then this guy will be good. Control C to stop something that's hanging. Go build. And what I did was I just made it worse, because you'll notice my total time is 4 milliseconds, because what I did was all 9 of these things kicked off, and then I immediately closed the channel, which means after the second that this takes, when it goes to write the channel, it's going to say, oh, this channel's closed, and it can't put anything on it. We have a signaling problem. Well, we don't have a signaling problem because Go has this other cool thing, which is called a wait group. And that's how we're going to fix this. So let's do var wg, and this is in the sync package. So sync.wait group. Okay, a wait group is a very complicated object that has 3 functions. Okay, not complicated at all. It has an add, it has a done, and it has a wait. So this is something that we can use. Basically, it's reference counting. So add takes a parameter, so add 1. Done, so it adds 1 to the internal counter. Done subtracts 1 from the internal counter. Wait waits for the counter to be 0. So we can use this as a signaling operation. So the idea is that here I could say, okay, in my loop, wg.add 1. And I wish it just kind of defaulted to 1. That would be awesome, but you have to say 1. You can actually say -1 if you want as well, but don't do that. And then down here, I could say wg.wait. And so say, okay, well, once the wait group is done, then close the channel. Now, the trick is inside the asynchronous process, I need to access that wait group so I can decrement it. So we'll add another parameter, which is a pointer to a wait group. So we do need to have a pointer to the wait group because we need to modify the wait group from inside of this function. So we do have to pass it by reference rather than value. And we'll say ampersand WG when we call this. So that'll give us our wait group. And then at the top of this function, I can say defer wait group dot done. And again, done subtracts 1. It's not a completely complete. And so again, whether this hits the error path or the happy path, the wait group will be decremented. And so by doing this, go build. Now it's working again. And where this is kind of more important with working is if we get errors. So let's go and do this ×2 again on the ID so that we get a mixture of errors and happy path on this asynchronous process. And so we can see I got 5 errors, I got 4 successes. My application completed because regardless of whether there's an error or not, my wait group got decremented. And this wait group.wait will wait for everything to be done before it closes the channel. And then looping through the range of the channel line 87 works. So that I think that's really cool. Does anyone else excited about this?
It appears like closing a channel closes it to writes, but not to reads. Is that right?
Well, so I mentioned that if you read off a channel that's empty, it's a blocking operation. On a closed channel, if you read off of a closed empty channel, it doesn't block. It's more complicated. It actually, when you read off a channel, it returns 2 values. It returns the value plus a Boolean that's okay or not. So you can actually technically check that. If you want to see the details of that, I would say go look at the article that I have about channels on. Where's my where am I? Oh, my GitHub repo went away. Boop. Okay. Back to the GitHub repo, there is a thing on channels, wait groups, and anonymous functions. And so this goes into more details about how the blocking works and how the closing works. So here, the channel, when you read off it, technically returns a value and an okay. So you can say, well, if it's not okay, that means the channel's closed. The value you got back isn't valid, so you could skip over it. So there's a little bit more with regard to channels. Okay, one last question. 5 more minutes for anonymous functions. Yes or no? Thumbs up? Okay, well, for those of you who don't want to stick around, thank you for joining me this evening. I do have some thumbs ups, so I'm going to do anonymous functions because another thing that I like in the C# world are lambda expressions and anonymous delegates. And the way that I did this with a separate, let's go back to line 81, the separate go with a named function is actually not done very frequently. Most of the time, people will use inline functions for go routines. So let's see what that looks like. Now, an anonymous function is very similar to an anonymous delegate in the C# world. And the way we create it is we inline the function rather than having something with a separate name. So in this case, I'm going to take the parameters and the method body of the get person to channel, which I hate the name of this, so it's going to go away. That's good. So I'm going to copy all of this. And then I'm going to replace this get person to channel, just the name, with what I just copied. I'm going to keep the parameters at the end. I'll talk about those in a minute. And then I'm just going to add a func. So this is now an anonymous function, which is an inline function. It does the same thing that we just looked at. Now, by having the parameters after this, this immediately calls this anonymous function. So rather than having this anonymous function that's assigned to a variable or something, we are immediately calling it. So if we have the parameters afterwards, we're immediately calling this anonymous function. And that means that I can get rid of this named function. So we'll get rid of that. And then go build and run just to see so it works. And it only takes 1 second now, which is awesome. So now that we have this inline function, we can do a couple things to it, because similar to anonymous delegates and lambda expressions in the C# world, we can have captured variables, or what are known as closures in the rest of the universe. And Go refers to them as closures as well. So what that means is I can get rid of this WG parameter that I have on this anonymous function. And this WG that I have on line 72 refers to the same one on line 67. So there's the outer scope. And so we're basically saying, okay, we're going to capture this WG variable inside our anonymous function. And we do that. Now, one thing I like about that is now that pointer variable goes away. Yay. I like that. Excuse me. Let's do a go build and run it again. Results are going to be exactly the same. Excuse me. Now we can do the same thing with the channel parameter. So I can delete the channel parameter and the argument that's passed in. And the channel that we have here on line 78 refers to the same variable we have on line 66. Now, it's a little confusing because our parameters had the same name as our outer variables, but we're actually using the same items now. And then again, we'll just do a build and a run, and we'll see we get the same results. Now, there's also the same problem that lambda expressions and anonymous delegates have in C#, which is it's a really bad idea to capture an indexer, because it's really tempting to say, oh, well, I'll just capture this ID as well. So now I have this ID refers to the ID that's part of this for loop. And you'll notice I still need the parentheses on line 79 because I'm calling it, but because there's no parameters, they can be empty parentheses. This kind of messes up our application a bit, because notice our values that come out. They're mostly 9s with a 4 and a 7 dug in there. And if we do it a couple times, those values aren't always the same. Here's a 2 and a bunch of 9s. And here's a 4 and a 6 and a bunch of 9s. And that's because capturing an indexer is dangerous, because when we capture a variable, the value that it has is the value at the time it's used, not the value at the time it's captured. So because of the timing of all of this, and this is why we're getting weird things here, the value gets to 9 before these functions are complete. And so that's why we're getting this weird behavior. We're basically kind of getting the final value of the variable, but because of timing issues, we're grabbing a couple before it gets there. Now, the good thing is the Go extension recognizes this. I do have yellow squigglies on line 73 and 75, and it says loop variable ID captured by func literal. So it's saying, that's a bad idea. You might want to rethink that. And so let's go ahead and put this back. ID int, and then we'll put ID back at the bottom. So instead of capturing it, we're actually passing it into the function. And the value when we pass it in, again, passed by value, will be the value at the time the function is called, and that's not mutable once it's inside the function. So that's why this works. And let's just go build this again. And we'll see. Now we have our 9 values, again, in no particular order. So I like having the inline function because now I don't have to worry about the channel parameter. Now I don't have to worry about the pointer to the weight group parameter. And it just seems a little bit cleaner. I'm going to do one more thing, and then we'll call it a night. And that is, I'm going to take this wait and close and run this asynchronously as well. So I'll say go func, and this will be a function that takes no parameters. And then we'll just wrap the curly braces around these and add the empty parentheses at the end to call this anonymous function. And what this will do is it will wait and close on a concurrent operation. Now, we're not going to see any difference in our particular run for our application because it's not doing anything very complicated. And what this is doing is kind of subtle, because what we're saying, what we had before with the wait and the close was saying, you know what, line 87, this for loop cannot start until after you're done waiting. But if we take this wait group and close and run them in a concurrent process, now we're saying, you know what, this for loop can start going right now. And it will keep going until this concurrent operation is done waiting and cause close. And then, you know, this range of channel on line 87 completes. So it's kind of very subtle, but interesting, which is, well, I can just kind of wrap lines of code in an anonymous function and make it a Go routine. And now it's running concurrently. And that's kind of cool. And I get way too excited about that.
If you added a thread.sleep on line 70, would that effect become more obvious?
Thread.sleep. Actually, it might. Well, let's see what happens. There is a time.sleep. And the duration, here's the interesting way you do duration. Let's say 3 times time.second. Okay. So that'll sleep for 3 seconds, which may be too much.
I was thinking like 300 milliseconds or maybe 500 milliseconds, because then they'll start to zipper in interesting ways.
Yeah, but you're not thinking big enough.
Can you do it
Okay.
like 3 times the index?
Yeah, if you wanted to do that. Now okay, what's 3 times 9? That's 27 seconds. We're gonna wait half a minute. Okay, Rob, you were
just
right.
2
This is too
times
long.
the half of the index.
Yeah. But you know what? I've started this, so I'm gonna wait my 27 seconds. Come on, you can do it. No? Okay, there we go. Look, 28 seconds. Okay, I even calculated it kind of good. Okay, but let's get rid of the synchronous one and make the wait asynchronous. And now what we should see is we should see them bop in every 3 seconds or so. Go build, if I'm thinking about this correctly. Come on, you can do it. No? Come on. Oh, yeah. The wait is in the for loop. So that's blocking. Line 71 is blocking. So the for loop is actually going to take 27 seconds to complete. So let's get rid of that. Let's put it inside the anonymous function instead.
Well, if we put
'Cause
it inside the
that's
anonymous
going to be
function,
blocking.
then it's
Yeah, you know what? You're right.
yeah.
I don't think there's a way. I see what you're saying, Rob. I would have to think about it more, but I don't think there's a way to get there from here, because having the sleep inside the for will prevent this from finishing.
You're right.
So it's preventing the for loop from finishing. So we're not going to get down here. Okay, you know what? I'm going to do it. I'm
So
going to do
maybe
it.
put it inside.
This is actually
the,
something I do in C#. Watch this. I'm going to start listening before there's anything in there and wrap this in a
Good
Go
call.
Funk. I've actually done this in my C# code. Oops. Okay, and now I'm just going way off script. Okay, so what I'm doing is, before I'm doing any writing, I'm starting off my read operation asynchronously. This gets better and better. Now this should be interleaved. Come on. Yeah, there we go. So every 3 seconds, we're going to get a new value, because I've said, you know what, my reading is going to be an asynchronous operation. So even though this for loop is synchronous, it's still going to keep going. And okay, I can't wait for that to finish.
So for the math, if you made it so that the one that's number 9 took the least amount of time and the one that's number 1 took the most, so something
Yeah, we
along
can do
that line, that way we would see number 9. So dealing with the ID.
Let's say 1 times time dot second times index. Oh, it doesn't like that. Maybe if I add some parentheses. Oh, come on. Index times. Oh. Mismatch types int and duration. So time dot second is a duration. Now, see, I don't know why you can do that and it's not mismatched. I don't understand.
Can you cast it to be the right type?
Cast it to a duration. Let's see. I don't. I totally see where you're going. Okay, you know what? I'm gonna cheat it. I'm gonna cheat it. I'm gonna cheat it.
I was trying to get to the point where 9 took 1 second and 1 took like 9 seconds or something.
Yeah. Okay, I can come
For
up
J
with
equals
a
index
crafty way
to
of doing
range
this.
dot length IDs. The hard part, though, is because we're now reading asynchronously.
Yeah.
Launching, closing the channel synchronously or asynchronously is kind of lost, because we're still draining before we close.
To index index or I greater than 0. Okay, I'm getting closer. I minus minus. Okay, so but we want to go backwards. 9. Okay. I want a 1 to be a 9.
I equals index. I is less than len IDs, I plus plus.
Less than len IDs, I++. Is that going backwards though?
It's getting
oh,
smaller.
Yeah, okay,
because
yeah.
it's
that
going
actually works.
forwards less.
Yeah. Okay, now we're just goofing. Let's see. So 9 should come up first. Did I save? Wow, I messed that one up. Oh no, so this is still 1 will take, they're not going to come up in a different order because again, this for loop is synchronous. So what will happen is the 1 took 9 seconds, the 2 took 8 seconds, the 3 took, so it's going to speed up as it goes down the list, but they're going to still come in the same order. To get them to come in different orders, we'd have to put the sleep inside the go func for different lengths. Okay. Wait. Oh, fun. It didn't do them all. That's fun. Oh, but if I put it in there, it's going to capture the indexer. Okay, I'm going to have to think about that. But that's an intriguing thing to try to get them to come in backwards, which is totally doable. But I think you have to put the sleep inside the go func. So line 80, I think it needs to be inside there.
And instead of just backwards, you actually could do it where you do a random value between, 1 and 3 seconds.
Mm-hmm.
And then it would come back in various orders.
Well, it already comes back in various orders if we take this part out, right? It's non-deterministic. So I don't know if we'd be able to know when it was done or not. Ooh. Oh, look, I messed that up completely.
It has to do with the function close, I think.
Yeah, I think we're probably closing it. Let's see. Yeah, it's the this add 1 isn't happening fast enough. Wait, that doesn't make sense. Am I saved? Because the add 1 should happen before the wait and close. The channel will be open up here. I don't think this has a problem with the empty channel. Would it have a problem with the empty channel? I don't think it does. Well, now I'm back to where I started without the asynchronous. Okay, I don't know where we ended up, but I basically removed all of the asynchrony. So good job, Jeremy.
That was so much fun watching you think through it, though. That was really cool.
Yeah, well, so a pattern that I have used in the C# world is having a separate producer and listener. So the producer is generating values. In my case, it's a machine learning thing that takes 1/3 of a second for each thing. And then there's a listener that pulls things off of the channel as soon as they're available. So in that scenario, I kick off the listener concurrently in a task, and then the producer also runs in tasks. And so as the first things start to produce, then the listener can start pulling things off immediately. So I would need to think through exactly what it's doing in Go. It could be that the channel shouldn't be closed. It's okay for a channel to be empty, but this should block until the channel is closed. I'd need to work through this a little bit more to see exactly what this is doing.
Is there a way to debug Go?
Probably. I don't know what it is. And all of my trying to run through Visual Studio have been unsuccessful. So this is a standard error that I get. Oh, but it's actually doing something. So it's running the function, but there's something not right. So it's like it's running, but not debugging. I don't know.
You've only opened a file. What if you go back to the folder and type in code space dot? That'll open the folder. And then if you go into the debugger there, it should give you a different option to be able to create that launch.json file that will allow you to debug, hopefully.
And I actually
dot.
don't know what that is for for Go, which is my problem. So
it's good at guessing, actually.
Oh, Go, that's not Go. That's
on the left, click on the debugger group.
This guy.
Create a launch JSON file. Oh, I was wrong. It didn't prompt you to
add configurations. Hey, look at this. Go launch. What do you think? Launch file?
Yeah. Ooh. $. File will take the current file that you're editing. Since you only have one, that might be perfect.
You think that'll work? Okay. I'll try it. Give it a shot. So start debugging.
Switch over to main.go.
Main.go.
Now do it.
Okay. Start debugging. Oh, okay. Look, I have a thing. Oh, that appears to be working. Okay, Rob, you're a genius. Let's take a breakpoint here. Bing. Exited with code 0. Okay, that exit code, that OS exit 1 would give us the 1 there. Let's try it again. Will it stop? Hey, look at that. Okay, so apparently that's how you do a debugger. Okay,
I really like how you have VS Live Share installed as well.
Oh yeah, I have
VS Live Share
meaning
present to the user group and get everyone to talk through the Zoom channel.
This is how it works. Okay, so channel. Okay, I don't know what this means for what the channel is. Send 0, receive 0. Anyway. Breakpoint, breakpoint, breakpoint. Okay. So apparently that works. Stop. Save. Run. Okay, I got the exit. Oh, but breaking and concurrent stuff can be a problem. Closed 0. Okay, so I'm assuming that this channel is not closed. So if I step over. Yeah, I'm not sure why.
While you were debugging, the other thing decided to close it because it was also empty.
Yeah, because the wait group.
What's cool though is now you'll have a debugger where you can go look through it and see. Is there a concept of lambdas inside Go? Like, could I create a function and pass it in as a parameter into another function?
Yes. So function is a type. So like our anonymous function we just created, I could assign that to a variable. And you can pass them as parameters. Off the top of my head, I don't know what the syntax is. You might have to give it a named type, but yes, that is definitely something that is part of Go.
So you might want to break point on the close to see when it hits that and see what's been processed.
And on the close. Okay, I can tell we're going to be here very late. Okay, we didn't hit the close. Let's put a breakpoint there. We're obviously hitting the total time. Start debugging. Yeah, see, we're not hitting the close. Oh, the application's exiting before any of this could happen. You know what? I've had this problem before. So yeah, that's actually what's happening. So all of this stuff is still working, but because all three of these sections are asynchronous, I would really need to make this not asynchronous anymore in order for this to work. There we go. So if I do this, so our program is exiting prematurely is what's happening. I should have recognized that because I've had that problem so many times. Okay, it's still exiting prematurely. But now I get a value back after 1 second. Let's see, add one. Okay, I might have to stop on this because I've been talking for 2.5 hours and my brain might be a little gone by now. I will answer a question. As a C# native, how do you feel about Go? I like Go from the simplicity standpoint. The other thing that's kind of interesting is, let me go to I like how easy it is to spin up a web service. So one other thing that I did in the repo is, in addition to the .NET people service, I have a Go people service. And so this is the same functionality as the .NET service, but in Go. And it's about 88 lines of code. And most of that code, if you look at from this point down, line 50 down, this is just creating the hard-coded person list. So this is defining the person struct, creating the hard-coded list, have one for a get person versus a get people. So that's really the functionality of the person people, the person object and the people grouping, to actually make this bigger. Kick things off. So in this case, like I said, I'm using Gorilla Mux because pulling the ID property off of the URL. But what you can do is set a path, a route, and assign it a handler. So people/IDs is assigned to the ID handler function. And the ID handler, or all the handler functions, take an HTTP response writer and a pointer to the request. And so I do my processing. And then since this is a response writer, it's an IO writer, which has a write method. And I'm feeling like I should have pop-ups here, but I'm in GitHub. And the write function takes a byte array. So in this case, I get the collection of people objects. This is manually creating a slice based on the length of the items coming back. And then what I do is I'm pulling out the individual ID. So this is a little complicated because I'm getting the people collection, trying to get the ID property off of it, and then sticking them into the slice that I can return. So these 5 lines are processing the data. And then once I have my data, do a JSON.marshal to turn that into JSON, which returns a byte array that I can pass to the output. The get people is simpler because all I do is I call the get people function that returns me the slice of person objects, just marshal that whole thing to JSON and send it out. And then for the individual person, there's a little bit more because I have to parse the variable. So and this is coming from the Gorilla Mux. There's nothing built in for this. So to get the ID property, basically this format is, this is a regex. So it's saying I can pass in digits and any number of digits. Those will be assigned to an ID key, so key value. And then the mux.vars is that collection of key value pairs. So I get that out. It's a string. Because it's a string, do a string convert to convert it to an integer, and then call the get person. If it's empty, I return a no content because that's what the .NET one does. Marshal it and send it out. So it's really kind of short. And what they're doing in the C# world is kind of the same thing, or I should say the ASP.NET world, because they're actually heading in this direction saying, okay, well, rather than having this service infrastructure with the controllers and everything, we're going to just make, routes and handlers, routes and handlers, routes and handlers. So this is coming soon to the ASP.NET world. So again,
I pass a 200-digit number to the people, the get person by ID function. Will I crash your web server?
probably. Well, it depends. So the A2I, I'm assuming that A2I will overflow. I'm sure an overflow is a panic, or I'm not sure. I'm guessing that an overflow is a panic, saying you can't recover. So if there's a panic, that's what's interesting about this. You see this log fatal. Oh, I guess I should have described this more. So there's these function handlers that are assigned to these routes. And then this HTTP handle, this RTR, this is all the Gorilla Mux stuff. So it's the third party thing. And basically you take that and assign it to the standard HTTP routing stuff. And then you say listen and serve. And the listen and serve is what actually starts up the web server. So I'm saying, hey, start at this location. And this has a log fatal. So if there's a panic, then there'll be a log fatal. So again, it will exit with a non-zero. So I get alerted to that. Theoretically, I could restart my server. So this is very naive at this point, but it's interesting. And I do see something in the chat that says, don't ignore errors. And yes, I don't like that this ignores errors, but it has the same behavior as the C# code, which also ignores errors. So I was trying to do a one-to-one comparison when I wrote this. Now, quite honestly, the errors that I'm ignoring, yeah, so line 43 would be the one I'm concerned about, which is taking Rob's value that he wants to do to break my thing and actually check that error. The other errors, because I have full control over this struct and the data that's coming in, it's all hard coded. I'm not concerned about the JSON marshalling erroring. I guess theoretically it could. Yeah, this one definitely should be checking for that. And then same thing here. This is a JSON marshalling known data, JSON marshalling no data. So yes, I will agree. The error on line 43 should not be ignored. Okay. So that's what we did. There's additional topics. Thank you for hanging around. This was a really, the problem is you let me talk and I will talk to fill any space available. There are a lot of interesting topics. So again, here's kind of the list of additional things to look at. We actually covered a lot of them. So the inline goroutines, the closures, and the wait group, we looked at those. The interfaces we looked at a little bit. Packages and exports, didn't really look at those much at all except the built-in packages. And I didn't really talk about named return values and bare returns. Those are kind of interesting too. But again, I have articles on some of these. I have a whole article on error handling and some of these other things. So if you are interested, again, head out to the GitHub repo. You can get there from my site, jeremybytes.com, or github.com, Jeremy Bytes, and there's a Go for the C# developer that is out there. Any other questions?
Is your site really still HTTP?
Yes, it is.
Can I help you with that?
If you'd like, but I don't actually have any input. It's basically a static HTML site. Yeah, I haven't put any effort into that because there's not, I guess, man in the middle stuff, but there's no, I'm not collecting any user data. But yes, you can help me with that. I know Google has started saying if it's HTTP, we don't care about it. But most of my indexing is through my blog, which is on a Google site. So that actually is HTTPS. Okay, cool. Well, thank you so much for joining me.
This was so amazing. Thank you for taking us through all of the things that is Go and comparing and contrasting it with our experience in C#. That was amazing. And thanks for letting us get you off track. And it was so much fun to be able to get to interact with you and ask you interesting questions and go in strange directions you hadn't even thought of before. This worked out really, really well.
Yeah.
Thank you.
I appreciate that as well, because otherwise I'm talking into my camera and that is so boring on my end. So yeah, thank you. Thank you for being interactive.